Some alternative definitions of subgroup also we have. So these are alternative definitions of subgroup. You know this definition of subgroup, right? Yes or no? You know this definition of subgroup, right? And one alternative definition I told you. What is alternative definition? One alternative definition we have already seen. See, this definition you already know. You have a subgroup, then this must happen. This definition you already know for the subgroup. Identity element must be there, closure property must be there, inverse property must be there. So this is the definition of subgroup you already know. One alternative definition we have already seen. Can anyone tell me what is that? One alternative definition we have already seen. What is that? Just remove it. And what you do? Just remove it and what to do? A non-empty. A non-empty. Just put a non-empty. Just put non-empty here. This we have already seen. Very good. Okay. So remember, this is the definition of subgroup. But alternative definition is remove this first condition. This first condition you remove and put non-empty here. Now you can notice this is alternative definition. There is one more definition. What you can do, you can mix them. You can mix these two. You can mix them. So these two you can mix. These two you can mix, means merge. You can merge these two. And you will get another definition. And that will be that for all A comma B, A star B inverse belongs to H. So you can merge these two. Is this clear? For all A comma B, A star B inverse belongs to H. So this will give you another alternative definition. So this is alternative definition. This is another alternative definition. What is another alternative definition? Just remove this and mix them. Remove this and mix them, merge them. These two things you merge. So only one thing you need to check, and what is that? For all A comma B, A star B inverse belongs to H. Okay. Is this idea clear? What I'm saying? Just merge these two. This is your alternative definition. So many people, they use only this definition. So just merge and finally you will get this definition you will get. So these are the alternative definitions of subgroup. Are they clear? So alternative definitions of subgroup, are they clear to everyone? This is the original definition you already know. This definition we have seen. This we have seen. And you can merge these two. Then you can see another. So three definitions we have seen. In the GATE exam, this definition has been asked. Let me tell you. Let me tell you this third definition. This is your another third definition. This has come in the GATE exam. Okay, only three are there. Let me tell you. So I promise you only three definitions are there. There are no other definitions. So you don't have to worry. Only three definitions we have. And there is an important thing. We will not prove it. But if you have a finite group, then only closure property you have to check. So this is important thing that you can say. If you have a finite group, if G is finite, this will only happen for finite group. Okay, if G is finite group, then which properties you have to check? Then to check H is subgroup or not. To H is subgroup or not. What property you need to check? Subgroup of G or not. We only have to check closure property of H. Okay, if G is a finite group, this will only happen for the finite group. So if G is finite group, then to check, okay, I can say to check H is subgroup of G or not, H is subgroup of G or not, only closure property is needed. Only closure property needed. Only closure property needed to check. To check. Only closure property of H is needed to check. Nothing else. So, but this will happen only for finite group. Only for finite group this will happen that. Only for finite group this will happen that. Just check the closure property. Only closure property you need to check. So this is the statement. This theorem. This theorem says that if you have a subset of finite group, if you have a subset of finite group, then it is a subgroup if and only if it is non-empty and closure property. Just closure property you needed. Okay, is this clear? Only closure property you need to check, and non-empty, of course, non-empty. This should be non-empty. This should be non-empty. So if G is group, let's assume G is group, and let's assume H is subset of G. H is subset of G. Then to check, remember H is subset. This is the symbol of subset. Now to check if H is subgroup, what you need, tell me? To check if H is subgroup, what you need? To check if H is subgroup, what you need? You need to check that identity element must be there. And also you need to check closure property of H. Closure property of H. And you need to check inverse property of H. Inverse property of H. This is what you need to do, right? Agree? Yes or no? If you want to check whether H is subgroup, subgroup means subset which is a group. Subgroup means subset which is a group. Subgroup means subset which is a group. Subset which is a group. So these things you have to check. Do you need to check associative property? Do you need to check associative property? Associative property will be borrowed from here. Operation is not changing. Operation is not changing, so you don't need to check associative property. Operation is not changing. You are defining subgroup. So operation is not changing. So associative property you don't have to check. There is no need to check associative property. These properties you have to check. Associative property you don't have to check. Associative, it will be associative because operation is same. You are not changing the operation. So that is the reason you don't have to check the associative property. The remaining property you have to check. Now I am saying that if you have a finite group, now notice, if you have a finite group, then things will change. If G is a finite group, now you don't have to check. Now you don't have to check this. Now you don't have to check this. You only have to check two things. Okay, one is non-empty and another is closure property. This is what I'm saying. This is what I'm saying. So if your group is finite group, if your group is finite group, then to check whether H is subgroup, only these two things you need. It should be non-empty and closure property you need to check. That's it.